You have the floor, Mr. Nanja.
Ajit, are you starting?
Hello, everyone. Greetings from Cairo, and good afternoon, or good morning, or good evening to all of you from wherever you are attending. And this session at the Cairo Water Week, session 5.3, that's the title is Measured and Remote Sensing Based ET Determinations, Results, Learnings, and Applications. And this is a session that we have put together in collaboration with FAO under the Regional Water Scarcity Initiative, and showcasing the lessons we have learned about ET observations that we have been doing for the last 2 years in different ecosystems in the Middle East and North Africa region. So far, such a coordinated observational network was absent, and considering the need of the hour, this observational network has been established, and this session focuses on the lessons learned from this network. And it's my pleasure to introduce Vinay Nangia, who is the ICADA principal investigator for this project. And to introduce Vinay, he is a research team leader of the Soil, Water, and Agronomy team of ICADA, and he is also the adjunct faculty of Texas A&M University in the USA. And his background is in agriculture water management from both observational and modeling perspective. And he has received a PhD. His academic background is quite diverse, and he has a PhD in water resources and 2 master's degree in biosystems and agriculture engineering, both from Minnesota State University. And with that, I introduce, I welcome Vinay. Vinay, please.
Thank you, Ajit, and welcome participants, dear colleagues, distinguished guests. Welcome to this technical session. And this technical session actually relates to the previous one that we were in just now. Maybe some of you were with us, the one that was called Remote Sensing Determination of Evapotranspiration. And after the break, now we are coming here, so it's a back-to-back session. In fact, the determination of evapotranspiration using satellite remote sensing requires ground truthing verification. So this can be done with several methods, including, for instance, in covariance, Bowen ratio, using lysimeters, and soil water balance, and so on and so forth. So now these methods have their own limitations, their own uncertainties, and a series of webinars have been conducted dedicated to these topics. And we have invited expert presenters to build on this background knowledge and try to build some capacity in the region on ET measurement and what are the strengths and weaknesses and uncertainties. However, one of the most important projects for ICADA and for FAO Water Scarcity Initiative has been the conceiving and establishment of a partnership of a regional network of evapotranspiration measurement sites. Today, you will hear 5 implementing partners from Egypt, Lebanon, Jordan, Morocco, and Tunisia, talking about their experience in the past 2 years, measuring evapotranspiration, followed by a presentation that talks about the comparison of measured with the remote sensing methods and how do the compare. And soon we will be including Algeria, Palestine, and Sudan going forward in this network. So without taking too much of your time, I would like to kickstart this webinar. But before doing that, I want to introduce my co-chair, Dr. Mohammed Al-Hamdi, who is with the FAO Regional Office Near East and North Africa, and who is the delivery manager for the Water Scarcity Initiative. He will be co-chairing this session with me. And so welcome, Dr. Hamdi. And I also want to acknowledge that this session is being organized between ICARDA, FAO, and CEDA. And with that, without taking too much of time, let's move into the presentations, which will be followed by a panel discussion and then Q&A with the audience. And so Ajit, back to you. If you want to get started with introducing the presenters. Thank you.
Yes, I will share my screen. Can anyone confirm if you can see my screen?
No,
hello?
no. Yeah.
Okay. Not yet?
No, not yet.
Ajit, you may simply start by introducing the speakers. It's a very tight program.
Yeah, today we have 6 speakers. First of all, 6 speakers who are the national, the principal investigators for each of these sites where we have the ET measurements. From Egypt, we have Dr. Ala Mossad. He's an assistant researcher at the Water Requirements and Field Irrigation Research Department in Siveri, Egypt. And he has a master's in soils and water sciences from Carfreshil University. And for Lebanon, we have Dr. Ihab Joma. He's a researcher and lecturer. He is the head of the Irrigation and Agrometeorology Department at the Lebanese Agriculture Research Institute. And he's also responsible for managing 60 automated weather stations across Lebanon. And for Morocco, we have Dr. Ehsan El Maknasi, who is the chief engineer of rural engineering, lecturer and researcher in the Department of Rural Engineering at IAV. She's managing the site in Morocco. And for Tunisia, we have Dr. Rim Zitouna Shebi. She has a PhD in water and soil sciences from the University in Supagro, Montpellier, and has a master's in horticulture sciences from the National Agronomic Institute of Tunisia. For Jordan, we have Dr. Naim Masri, who is the Assistant Director General for NARC in Jordan, National Agriculture Research Center in Jordan. He's an experienced researcher in the field of lysimeter-based evapotranspiration estimations. After these 5 presentations, we will switch the gear a bit, and we will go to another scale where we will talk about comparison of these field observations with remote sensing retrievals. For that, we have Dr. Chandrasekhar Biradar, who is a principal agroecosystem scientist and head of the ICARDA geoinformatics section. And he has a lot of experience in estimation of biophysical properties from space for multiple remote sensing domains. These are our speakers today, and after their expert talks, we will ask them specific questions about their views on a specific question, which I will announce later. Maybe I will start with my presentation, which will give an overview of the project itself. Can you still see my screen? Can anyone confirm?
No, Ajit, nobody can see your screen. Can you retry?
What now?
Would you please cancel sharing your screen and try again? Click on the green button that's called share screen and try to share the whole screen once more. Yeah, we can see it now.
Okay, sorry for the small technical glitch. So yeah, my talk is titled the NINA ET Network, a platform for collective regional intelligence on enhancing water productivity with coordinated biophysical measurements. So just to introduce the topic, this region is highly vulnerable to climate change. This region is already dry, and there are parts of the MENA region which are extremely prone to declining precipitation, especially regions in the Maghreb region, like Morocco, Algeria, and Tunisia. We have statistical confidence that the precipitation will definitely decline as the climate changes. But rest of MENA region, there is huge, very high statistical confidence that the temperature is increasing, but there is no specific confidence about the nature of precipitation. But as the temperature is increasing, there is a lot of indication about atmospheric process in terms of enhanced drying that can have an implication on evapotranspiration. And also in addition to annual dynamics, there is also changes in the season. All this can have immense implication on the cropping system. And this region being already dry, evapotranspiration is very, very important parameter, very, very important topic that we need to focus on in terms of agriculture water management and enhancing the sustainability of agriculture systems. So evapotranspiration is the ideal proxy for crop water management. Thus, understanding ET is a key to enhance water productivity in the MENA region. MENA is a fragile region in terms of climate change. It is likely to increase due to warmer and drier climates. There is a need to scale up techniques to enhance water productivity using remote sensing based modeling tools. There has been in the past also, there has been observational studies, but there has not, the challenge was how to coordinate all these things and how to coordinate these measurements so that it can be used in the scaling up approach. So that's why the scaling up is very important for taking adequate national policies. On the other hand, these measurements can also be useful for validating crop models that can be used to do ex-ante assessment like food security, how the food security will be there in the next few years under a changing climate. All these things can be done by crop models, but how to validate these crop models, for those things we need on the ground measurements. Then it also gives a platform for regional collaboration, capacity development, and attracting international attention. Evapotranspiration is such a fantastic biophysical process in which it is extremely, it can attract multiple disciplines, be it soil physics, be it remote sensing, be it boundary layer meteorology, be it ecosystem modeling. A lot of disciplines can be brought into the topic of evapotranspiration. So under this context of the NINA ET network, we have started with 5 sites spread across the NINA region. Lebanon, Jordan, Morocco, Tunisia, and Egypt. And these regions are very different in terms of climatology, but also different in terms of on-the-ground management. So at these 5 sites, we have different methods of multiple methods of remote sensing estimation, ET estimation. So it can be eddy covariance, energy balance, lysimeter, or the estimation of soil moisture in a consistent and continuous way, so that it can be used to retrieve ET proxy. But on the other hand, we also have a cost-effective instrument called Cordoba ET that can be used to measure ET on the ground. So if we are able to validate the Cordoba ET station, it can be used to scale up ET observations across the region. So that's the advantage of using a cost-effective ET measurement station. But the caveat is that these are approaches that are having big differences in methodology, difference in physics, difference in footprints. So we need to somehow integrate all of this and enrich our knowledge in ET mechanism and also develop strategies for scaling. So at these sites, we not only measure ET, but also measure a lot of auxiliary meteorological variables, meteorological, agronomic, and other types of variables. And the good thing about ET network is that we follow a consistent protocol in a coordinated way. As I mentioned, there has been a lot of isolated studies existing in the MENA region, but the important thing is that we have to bring them together under a common platform, under a standardized protocol, under a standardized protocol of not only data curation, but also quality control and archive. We have different levels of data, level 1, level 2, and level 3. Level 1 data is the raw data, half-hourly data with gaps, but level 2 data is the half-hourly data without gap. That gap has been filled, especially small gaps, not very large gaps. But level 3 data is the daily data, which can be used for remote sensing validation and many other operational use. But level 2 data, as I forgot to mention, that it can also be used for academic research and other types of intensive calibrations, validation and calibration. We have a very coordinated and very strict and very comprehensive protocol of data archiving that also includes quality control for different variables. And this is how we have been measuring and archiving different data sets. So there are lots of potential applications of this data that is generated from this network. First of all, and most important, is to calibrate and validate remote sensing based algorithms. And also it can be used to calibrate and validate crop modeling exercises. This data can also be used to do regional synthesis studies on crop water management and water productivity. We can create this platform for regional dialogue, co-learning, and capacity development for young scientists and postdocs and students. It can serve as a benchmark site for related coordinated regional observation experiments, not only for water cycle, but also things like carbon cycle and agronomy, etc. Serve as a platform to attract international collaboration and new projects, data sets for academic research as well as applied research can be obtained from this network. So with that, I will give the floor to other speakers. First of all, I will request Dr. Ala from Egypt to present the details from the site in Saka, which is in Egypt, in the Nile Delta. Welcome, Ala, please take the floor. Thank you.
Okay. Thank you, Dr. Let me share my screen.
Okay.
I think you're muted, Ala.
Yes.
Ala, you can start. We can see your screen and you're unmuted now. You may start.
Okay. Okay. Good afternoon, everybody. I will present briefly for not wasting the time. If we have a quick look on Egypt's site, it's an area of 10 faddans located in the northern part of Egypt, Kafr al-Sheikh Gabar Nuriet, Nile Delta region. Nile Delta region is the arable area of Egypt. It acts about 4.5% of the total area of Egypt. So our site is considered a good representation for the agricultural area of Egypt. It's a semi-arid region characterized by the Mediterranean climate. Soils here are heavy clay soils, salt-affected soils due to shallow water table that underlies at about 1 meter depth. Irrigation process depends mainly on the fresh water of the River Nile. The main object of evapotranspiration network project is to calibrate the evapotranspiration values captured from the remote sensing actions using a standardized protocol called Cordova ET system. It's an enhanced agrometeorological station, which was recently developed by Cordova University in Spain. It's a surface energy balance system, depends or measures the actual evapotranspiration based on some meteorological data like solar radiation, wind speed, canopy temperature, air temperature, relative humidity, and the vegetation indices. Other in-house field instruments like eddy covariance, energy balance, weighing gasometer, the soil moisture depletion method are used to test and calibrate the Cordova ET system. In Egypt site, the main observation method adopted for measuring the actual evapotranspiration is the energy balance system, where net radiation is measured using the net radiometer. Yes. You hear me? Hello?
Yes, Ala, please continue.
Okay.
Yes, Allah, please continue and be fast.
Sensible heat are measured using the sonic anemometer and the ground heat flux using the soil heat flux plates and the soil temperature thermocouples. Along the last 3 seasons we have passed, the energy balance system has performed very well and was seasonally maintained at the start of each season. Results and discussion. The first season was the winter season 2019-2020. The crop was wheat. It was planted in the 1st of December 2019 and harvested in the 13th of May 2020. Irrigation event has been performed for 4 times. Regarding the evapotranspiration calculations, the seasonal reference evapotranspiration was about 530 millimeter along the season. It was calculated using the Bellman-Montes equation based on meteorological data from in-house weather station. The graph of the reference evapotranspiration reflects the atmospheric demand from December to the May. The seasonal actual evapotranspiration was about 371 millimeter along the season, measured from the energy balance system. And the peak of the graph of the curve was in late February and early March. After about 70 to 85 days from planting date, it's the growth stage of the flowering. From ETA and ET node, we could update the crop coefficient. From its graph, we see that it reflects the different growth stages of for wheat crop from germination to maturity. The second season was the summer season 2020. The crop was corn. It was planted in 20 of July 2020 and harvested in 30 of October 2020. The seasonal actual evapotranspiration was about 330 millimeter, and the seasonal reference evapotranspiration was about 533 millimeter along this season. The third season was the winter season 2020-2021. It was wheat planted in 25 of November 2020 and harvested in 30 of April 2021. The seasonal value of reference evapotranspiration was about 550 millimeter, and the value of actual evapotranspiration was about 300 millimeter along the third season. The challenge we faced during the data collection, the global pandemic of COVID-19 affected everything badly. We met some issues with Cordoba ET system, like there were nighttime power cuts. The canopy temperature sensors was too high. Some nodes stopped working. There were some cuts in the cables of some sensors. Air temperature sensors were not working, and there was no ETA or ET node data available. So the site had many visits from FAO and Ministry of Water Resources to troubleshoot and fix those issues. The issues we met with the energy balance system were air temperature and relative humidity sensors were not functioning. There were some cuts in some cables of some sensors, and the issue of data gaps. So we held a maintenance at the start of each season. Conclusion and recommendations. The reference evapotranspiration was captured by the in-house method. The actual evapotranspiration was captured by energy balance, but there weren't other methods to compare. The data gaps need to be reduced by frequent checking of sensors in a proactive manner to avoid malfunction. Finally, the Cordoba ET system needs to be urgently repaired and made functional at this site. Thank you for your attention.
Thank you very much, Ala. Maybe as we are a little bit behind the time schedule, I will ask our next speaker, Dr. Naeem Masari. He is the Director General Assistant for Research, National Agriculture Research Center in Jordan. He has a lot of experience, as much as 20 years of experience in the field of agriculture water management. And he's an expert in light symmetry. And I invite Dr. Naeem.
Can you let Ramiz Mazare enter? He is Dr. Naeem. He's using that account to make the presentation. Ramiz, waiting in the lobby.
Sorry, what is the exact name of the presenter?
Ramiz.
Yes, I will search for it. Just a minute.
He could not use his Naeem Mazare account, so he's using Ramiz Mazare account.
What is his surname, please?
Mazahre.
Muzahi.
If it will take some time, we can start the next presentation instead. Hossam?
Okay, I'll ask him to send a bright and I'll let him in.
Okay. Ajit, why don't you introduce the next speaker while we let Naeem in? Yeah.
Yeah, I think in that case, we'll go to the next speaker. I will let me introduce you to Dr. Ihab Joma from Lebanon. As I mentioned earlier, He has been working at as he's a head of irrigation and agrometeorology department at LARI, and he's managing a lot of agrometeorological experiments in addition to the NINA ET project. So I welcome Ihab. Ihab, the floor is yours.
Hello, do you hear me?
Yes, loud and clear. You can put it in slideshow mode and start. We are slightly
Great,
scheduled, so
thank
if you
you.
could finish little ahead of time, that would be good to catch.
Okay, great. Thank you, Dr. Ajit. Thank you, Dr. Vinay. I just want to present the study case we have done at the measurement at the site in Lebanon, which is the research station, which is related to the Lebanese Agricultural Research Institute in the Bekaa Valley called Tel Amara. Why we need such kind of projects in the country, because of many reasons that everybody knows, but we have maybe more reasons to share with you. Of course, the shortage of water which we are facing, and the lowering of availability of water per person, the frequent drought that is happening. Of course, there is mismanagement and weak water management in the country that is also posing problems on the allocations of water over all the sectors. And in all cases, and everybody speaks about the overuse and the high use of agriculture, irrigation of the fresh water of the country. This is a big reason for us to step in as agriculture researchers to start working on this issue in order to help the country manage the water, low productivity of the water, and not yet brought to the scene. The productivity by itself, even the efficiency term has been used in the strategies. Not even the productivity. It's only used efficiency. Productivity is not yet used, and the efficiency is used instead of the term productivity. So we need to work on that issues. Crop water requirement for different crops. This is highly needed, probably in different regions of the country, because once we work on the evapotranspiration, it's like characterizing and zoning the area into different climate parameters or climate conditions. What we have at the site, we have a lysimeter, weighing lysimeter, that we are trying to make it on function with the help of this kind of project. Drainage lysimeter also exists. Automated weather station that we already have, but we also works with Cordoba under this project in order to calibrate and make this equipments that helps in evapotranspiration, active evapotranspiration estimation. Also through this project, we've got TDRs, soil moisture sensors, that are even better accuracy than what we had as FDR's soil moisture sensors. The site is located after the mountains of the Mount Lebanon's, on the inner side of the land, so it's an inner area. It's not faced by the sea, and the evapotranspiration might goes up to 1,500 millimeters a year, and there is no rain during the summer season. With an average rain of 550 millimeters a year. The soil is mostly clay soil to the deep soils, and with a pH nearby 8. This is just the site, just a photo shows the Cordoba station in the site collecting data. There is nodes. These are the small things here are the nodes that collects data from the field, and especially we're having the sensor, which is collects the canopy temperature sensor. The soil moisture sensors that were installed in 3 different localities within the field as TDR sensors and also our FDRs. For the first season of wheat, rain-fed wheat in 2019-2020, we have had a great correlation between what we are measuring as ET node and what Cordoba ET node is measuring, which will lead us to make a good correlation on the actual evapotranspiration computation. And this is the KC from our measurements and the measurements from ET Cordoba, which is also shows quite a bit of high correlation. The second season in summer 2020, we had potato crop, and these are strategic crops, by the way, for Lebanon. The potential evapotranspiration as ET node correlation was quite a bit of high correlation between what we are measuring and what we are estimating through the Cordoba weather station. And the actual evapotranspiration was measured through soil moisture depletion, which is we are still under functioning and updating the site in order for us to be able to better estimate the actual evapotranspiration. For the third season, which is faba bean, in 2021, winter 2020-21, that was the correlation between what we are measuring and in the field and what we had as from Cordoba and from the soil moisture depletion methods. What challenges we have had during the pandemic, as everybody else, and Cordoba station is still under calibration, let's say, and we still require to make quite a bit of updating and maintenance. We had some kind of discontinuity in the electric current, which we are using our equipment to communicate from in a room electrical current, so we needed. Soil moisture sensors required also specific communication issues in relation to, because it does not cover Lebanon. So we had to have a specific setup for us country. Economic crisis has hindered also us from sometimes regularly to reach the field. As perspectives and conclusions and lessons learned, working with ETA measurement are daily task monitoring. So we should do that on a daily task, checking on the data. Collection frequently needs to be checked frequently on the data in order to be sure about what we are collecting. Agronomic and crop data has to be also collected that will be somehow correlated and will lead us to better understand the active evapotranspiration. Somehow, as we have heard from different presentations lately from different scientists, the gravimetric methods that we used to rely on soil moisture depletion needs to be used only for checking, and because it's a bit difficult to work on this type of technical use of tool. Remote sensing, field monitoring images maybe could be used for knowing the homogeneity overall the field. Crop evapotranspiration as perspective and crop water requirement is better obtained through the measurements of actual evapotranspiration. Correlation of estimate and measured actual evapotranspiration is highly important for future plans and irrigation management, water management on a national level, and also on a research base. KC coefficient should be collected for various crops in order for us to understand the climate change issues that is happening, how it's affecting the crop water requirement. The canopy temperature that Cordoba has introduced has a good, so we saw it as a good tool and a good parameter to take into consideration for the calibration and for the estimation of actual evapotranspiration. I would like to say that the perspectives here, as I said, soil moisture should be brought to the scene, enhance the data collection standards in all the sites, introduce advanced equipments as much as we can. Variability of equipment will lead to better understand the system. If we can measure from different types of equipments, could be even much important for us to understand better the actual evapotranspiration. Homogenize equipments between regions will also lead us to understand different sites. ET monitoring network should have not to stop, should stay on collecting data with advanced technologies also, because it will push researchers to keep themselves on the top level of equipments, and also ensure good quality of data for the sake of the, being one of the whole network in all together. Thank you so much.
Thank you very much. I think there may be a lot of questions from the audience. So for the sake of maintaining the time, we'll go to the next presentation by Dr. Hassan El Nasi from Morocco. So I welcome Dr. Hassan. The floor is yours.
Thank you, Dr. Vinay. I will share my screen. Can you see?
Yes.
You can see. Just put it in slideshow mode, please.
Yeah.
I request all the remaining presenters to kindly maintain the time so that we can leave more room for panel discussions. Thank you.
Okay, thank you, Dr. Vinay. I will present the experiences and finding of establishing and operating sites for field measurement of actual crop water consumption in Morocco, in Bershit Plain especially. This project is done in the context of water scarcity. Mastering the control of crop water consumption is mandatory to improve agricultural water management, like water productivity, water accounting, and irrigation management. So this project, the NINA 80 project, led by ICARDA with the FAO, with a network of 5 NINA countries in order to build a common understanding of actual ET measurement. And using homogeneous experimental protocol. So in Morocco, a team from Agronomy and Veterinary Institute, Hassan II, have carried out ET measurement during 3 crop season in 3 sites in the Bershit Plain. So the studies area, as I said, conducted on 3 different sites. This is private farms, and the climate condition is, we are in Bershit in about 70 kilometers from the south of the Casablanca, the economic capital of Morocco. It's the semi-arid temperate climate. We are near the Atlantic Ocean. With the hygrometric degree of air always high. The temperature on average are 17.4 degree, and rain from autumn to winter, with the average rainfall 315 millimeters. So as I said, we had 3 sites experimental because we worked on 3 private farm, and we had to look for a better condition to conduct the experimentation. So we had to move every season with to look for a favorable condition to follow the experimentation. So the first site with the 6 hectare with drip irrigation system conducted with quinoa and maize between 22 February to the harvest in July, 3 July for quinoa and 11 July for maize. The second site here, 4 hectare with the drip irrigation system with the red beet and conducted between 8 August to 10 October. And the third season were 20 hectare on rainfield cultivation because it was a rainy year. So the farmer hadn't irrigate, and with the durum wheat, the crop, and the sowing on 20 February and harvest here on July. For ET measurement equipment, we had ED covariance facilitated by the Royal Center in Morocco for remote sensing. We had also an automated weather station by direction, National Meteorological Direction, and we have installed TDR with the relay to ED covariance to measure soil moisture, electrical conductivity, and soil temperature. And of course, Cortova ET station with a Frogit and 4 nodes. What is the protocol of ET measurement? We had, first of all, a field measurement. So beginning with a site preparation, like soil and water characterization and irrigation system installation. We had, as I said, the private farms. We followed agronomic practices like irrigation events, water applied, fertilizers, canopy height and canopy evolution, final dry biomass and yield. And with the troubleshooting and the reparation done during the season. The first step is data acquisition and treatment for equipment. We have done the data acquisition from ET Cortova, ET covariance, weather station with a half an hour and daily step. We calculate ET reference estimated with FAO Penman-Montet equation. We had done gap filling of missing data. As said by Dr. Ajit, we have filled templates L1, L2 for L1 for raw data, L2, L3 for gap filling, missing data, and daily data. And we have also made a meta file for a comprehensive of all data. The last step of our protocol is analysis to do analysis, interpretation, discussion, recommendation, and reporting of the season. So for the first season, first year, it was winter, or especially for Morocco, it was spring. The evapotranspiration, the reference was about 1412 millimeter. And ET measured by Bershid weather station was compared to ET Cortova, and the results show that both data trends are close. and follow a similar pattern. Total actual evapotranspiration in this season was 194 millimeters for maize and 121 for quinoa. And this graph shows the trend of crop coefficient that range between 0.2 and 1.7. The second season, this is summer season, and we have carried out with red beetroot crop. The reference evapotranspiration was total demand, atmospheric demand was 254 millimeter. Actual evapotranspiration 152 millimeters, calculated by energy balance method. And the ETA Cortova shows a spurious reading that are superior to ETO calculated. Crop coefficient development over the season range between 0.06 and 1.6. And the total irrigation dose provided is 380 millimeters that are larger, superior to the atmospheric demand. The last season, the second year and the first season of the third experimentation, we had done with wheat, durum wheat, and the reference evapotranspiration was 567. The actual evapotranspiration was estimated by 4 methods and shows that the energy balance method and ED covariance methods give similar values, as you can see here in this graphic. 295 millimeters and 282 millimeters. But ETA calculated by soil moisture depletion and measured by ET Cortova gave a different values. So crop coefficient development over the season range between 0.06 and 30.6. So what are the challenge? The first challenge is the limited access to the site for field measurement and maintenance due to COVID, like all countries. For ET Cortova, many times it stops functioning between period into 2020 and 2021, even if we when we replaced some component, but we had some dysfunctioning. We had also some problem related to experimentation on private farm. This is hard work for we hadn't the freedom to choose the crop or to manage the irrigation. So it was a little bit difficult. Complete knowledge of the functionality of the instrument and how to maintain it. It's important. We had help by ET Cortova, but for ED covariance, it's sometimes difficult. And the soil moisture depletion method doesn't give good results.
Hello, I see some.
Yeah. This is not my screen. I will share again.
Yeah, no, I think there is some technical glitch.
Yeah, okay. I will share again. Yeah, can you see?
Yeah, now I can see. Yeah.
Yeah, I move to the last slide quickly. No, this is not my my screen?
I don't know whose screen is this, but and moreover, I did not invite any breakout rooms. It's not my invitation.
Dr. Hassan, can you go to the concluding slide and
Yes,
on
yes.
share? Yeah, thank you.
Yeah, okay. So in conclusion, what are the key lessons learned? For each season, we learned from errors and constraints to improve the protocol and monitoring, and thus improve the quality of the data collected. The calibration of the new ET Cordoba station requires several measurement seasons and the replacement of faulty components. A uniform system of measurement using these ET methods will ensure quality data among all countries. As major conclusion, the Cordoba ET station can be used as a potential standard after calibration and improvement. And some recommendation here to continue measurement on a farm with favorable condition, calibration with remote sensing data, and the need to put in place tools to manage irrigation and optimize the doses provided to the crop size. As I showed, irrigation are superior to atmospheric demand. So on behalf of the Moroccan team, thank you very much.
Thank you very much, Dr. Hassan. Maybe we'll go to the next presentation by Dr. Rim Satouna from Tunisia. She's a senior scientist at the National Agronomic Institute of Tunisia. She holds a PhD in water and soil science from the University of Supagro, Montpellier, and she's an expert in agriculture water management. So Dr. Rim, the floor is yours. By the way, I did not invite anyone to the breakout rooms. There is some technical glitch. It's not me. Thank you for your understanding.
Yes, good morning, everyone, and let me present the case of Tunisia in this program. I present the study site, the ET measurement equipment and associated calculation results, and discuss some challenges faced during the collection data and conclusion. In frame of this program of establishing and operating a regional network, the EG covariance system is the main observation method adopted in Tunisia site for measuring ETA within the consortium agreement between ICAD and ENRCAF. The study site selected was in the northwest of Tunisia. It's Bousalem region, delegation of Jandouba. It belongs to the upper semi-arid biotic stage with mild winter. The average annual rainfall is around 450 millimeters, and with an inter and intra-annual irregularity. Annual temperature is reaches 18 degrees. The experimental plot has 2.4 hectares and was conducted using direct sowing. Until now, we conducted 2 rain-fed crop winter season, durum wheat and faba bean, and 2 irrigated summer season crop, corn and sorghum. I will present the 2 rain-fed crop results. The EG covariance system, the main measurement system, is equipped with 3-dimensional anemometer, sonic anemometer, it's a CSAT-3, with optical hygrometer, with a net radiometer, and soil heat fluxes. Then the 4 energy balance components were measured, which allow us to obtain ETA with a direct method or with indirect method as energy balance or Bowen ratio calculation. The treatment and the processing, with the raw data, 20 hertz data, 20 data per second, we treat this data, we do some corrections and obtain the 30 minutes data after control quality. With 30-minute data, we could have gaps. Then, in order to have complete data and to have daily data, we use gap filling methodology and for the sensible and latent heat, the two convective fluxes, and in order to have daily, then the daily data. Then this gap filling methodology allow us to obtain a complete series of actual evapotranspiration. I present the winter season, the first winter season, which is Durham winter. Here is presented the rain during this season. The ETO in blue, and ETA in red, direct measurement of ETA. The season, even we have many events of rainfall, but this rain were very low. They in the winter they didn't exceed the 10 millimeter, and it's one day in February, and also in the spring. The highest winter event was in the end of May, after the senescence of the crop. Then we can say that it was a dry season with many periods of lack of water, as in January and February and in the middle of April. ETO shows a classical trend with important low value in the winter, and it increases with the summer and reaching 6 millimeter per day in June. When comparing the ETA, ETA was between 2, it rarely exceed 2 millimeter, even with 3 millimeter, the maximum in April, with after rain and when the developing of the crop. And we can see that the majority of the year we have ETA less than ETO, then CASI is less than 1. And I can say also that we observe a rapid decay at the end of the cycle. This rapid decay was observed many times, usually observed in our Mediterranean side. The senescence was very, very rapid, less than 15 days. The monthly evapotranspiration analysis show that in here the ETO, the precipitation, the ETA with ETA, the CASI and the crop height. The majority of the maps which are in red here show a deficit of water, precipitation deficit in the winter season, December and February, and also in April, which are important season. The CASI was one or more than one only in the winter, when the vegetation is very low and is not developed. And in the developed season, the maximum of Cassie observed was in March, which is 0.9. The seasonal ETA is almost equal to precipitation. We have precipitation 297 and ETA 274. Then all the precipitation was used by the crop, the wheat crop. For the faba bean crop, we can observe also that the rain, we have less event of rain. The year was more dry than the wheat crop. But the ETA, long period, we have ETA as is equal to ETO, and but we observe some periods of stress as February here.
Excuse me.
Reem, I would appreciate if you could accelerate the presentation a bit because we're running late.
Seasonal results. The seasonal ETA of faba bean was 270, and which is larger than the precipitation. Then the crop uses the soil moisture in storage. As challenged, we have many damage due to cuts in the sensor cables. We have also contacts not to exceed the field due to COVID. In the summer season after 2020, it is scheduled that the corn crop will be conducted, but we have a problem of water management at the region, and the water was not available. As conclusion, we can learn the key lesson learned was that the comparison of several methods is a positive strategy to adapt. The energy balance closure is not always easily observable. The ETA directly measured by EC is judged as the best estimate of ETA for this site, owing to its magnitude relative to ETO, and the faba bean and wheat produce even if the years show water deficit. As recommendation, deep analysis of the hourly data are required before calculating daily and monthly ones. And gap filling method based on meteorological conditions are debatable for long gaps. And thank you for you, and thank you for all the team that participated in this field experimental phase. Thank you.
Thank you very much, Dr. Reem. I appreciate your presentation, and let me invite Dr. Naeem Azaria from Jordan for the next talk. He is recently the Director General Assistant for Research at NARC. So Dr. Naeem, the floor is yours. I would appreciate if you could highlight only the key results so that we can get adequate time for the panel discussion and the conclusion. Thank you very much. Dr. Naeem, I think you are muted.
You hear me, Ajit?
Yes, but I can't see your screen now. It was visible.
You see my screen?
No, not yet. It was there before, but now.
Oh, yeah. Okay. Okay, good afternoon. Today I want to present some results about our experiment, which is within the measured and remote sensing based ET determination for the establishing and operating of regional network field measurement to measure evapotranspiration by using the direct method, the lasometer, This is our experimental site. It is located in the central Jordan Valley at Deir Alla station, our research station, which is located under the sea level by 224 meters, and with the average annual rainfall about 270 millimeters, and the average annual temperature 26 degrees. The experimental plot size is 2 hectares. We planted 3 seasons or 3 crops: winter season, then the first wheat, then veg, 2 winter season, and the other in summer, which is maize, like the other countries. I use the large weighing lasometer with the 2 meter length and 2.4 meter width and 2.5 meter depth, and it is with the accuracy of 0.05 millimeter, which is accurate enough. What equipment I used in this experiment, as I said, the lasometer, and also we used a station from Cordoba for measuring or to evaluate the performance on measurement of actual evapotranspiration. In addition, we have another Campbell weather station beside the lasometer, and one in the outside, like this thing. This is in the side, and we have this in the place. We used in measuring the actual evapotranspiration the water balance equation. For the potential, we used Bellman-Monteith equation for measuring the potential evapotranspiration. The first is the result. I will go back to the result. We have in this figure the ET lasometer. Because of the COVID-19, we did not finish all the season. Maybe only we have at the mid-season, we have around 40 days, which is located in the mid-season, growing season, that we can achieve, and we can compare between the ET naught here, ET naught by itself. This is the for the weather station outside the field, which is yellow. And here we have for the lasometer, we see that the crop coefficient during this stage around 1. Also, we have Cordoba 80. It is maybe underestimate a little bit than the other, but maybe going with the same trend of the evapotranspiration. Now, the other season is for the, after that, we planted maize and the ET for different crops, as you see the ET for Cordoba and ET naught also for Cordoba we found, and ET for lasometer. We found that the ET for the lasometer, you can see that is looking from the initial stage, mid stage, and the end stage. For the and when we are comparing the potential evapotranspiration using the weather station outside, we can find it higher, especially when the plant going raised high, maybe reach 2 meter and 25 centimeters. Then the wind speed is very low during this period. Then the potential evapotranspiration measured by Cordoba or the in situ weather station inside the lasometer field, it is lower because mainly due to the wind speed. This is another, it is showing that what the wind speed at the beginning, they are the same for the Cordoba station and the in situ, the other weather station, while the outside, when the plant going high, more than 2 meters, going very low, then this means that we should use another weather station outside the field, especially when the field is torn like maize, to measure the crop coefficient.
Dr. Naik, I appreciate if you could highlight only the key results so that we have time for rest of the presentations.
Okay, this is the results. I will go fastly here. What we added during the season for the maize and the annual ET potential and the irrigation and the actual evapotranspiration by the crop, and this is the KC value. Here, the last season we are with the vetch, and this is maybe we have a good correlation between lasometer and Cordoba station actual evapotranspiration, while in the beginning is not. Here also for the potential, we found some correlation, but the always the 80 north outside, but more than that inside the lasometer. This is the vetch summary. We have 80 north and the participation with the irrigation and the actual evapotranspiration. Now the challenge, as the other countries, the access to the fields, especially in the first year. Also, some battery locked down for the Cordoba and the sensor, some problem and need from time to time to upload the software. The conclusion, we can say that this is a unique feature for well-functioning lasometer and elevation below the sea level. So it has the option to, if possible, with the other, as we now working. Recommendation, we need to deep analysis of hourly, based on the hourly better than the daily, then you can measure the daily. Analysis hourly are required before calculating daily also. Quality control gap filling is very important to do that. This is all I have. Thank you very much. Do you hear me, AJ?
Yes, thank you, Dr. Naim. Thank you so much.
Thank you.
Ajit, are you still there?
Ajit?
If not, I would like to invite our colleague, Dr. Chandrasekhar Biradar, who will make a presentation on comparison of remotely sensed evapotranspiration models and ground measurement in the MENA region. Chandra, you have about 7 minutes.
Thanks, Vinay. So I think we're already running out of the time. So can you hear me, everyone? Clear?
Yes, it's very clear.
Can you see my presentation?
Yes.
Okay, so great. So I'm not going to take much time because of it's already running 25 minutes, we're late. And enough discussion has been done in the morning sessions, and still so far the colleagues, what they presented in the different the countries as ground level measurements and validations. So I'll take straight direct to skip several of these slides and move to the what you call why remote sensing becomes so the important, and why especially a lot of the investment has been done in terms of the optical and the microwave, but still the land surface temperature put in the corner. So now there's a new innovations coming up, how best you can quantify with optical, with microwave to come to the high resolution remote sensing. And I moved to this one, why the pixels is so important, because we are working in a very small the farming systems, and land area is very little, and we need to look into the farming system level water dynamics, and look into the screen. I'm not sure if I can see this one. The little small white pixels is the sentinel optical data, and then we are relying on the 30 meters and 100 meters and 250 meters, 1000 meters. So basically the sentinel and Landsat and MODIS, that's what we quantify most of the remote sensing application at present. And look into the field size, how much each pixels is covered, 0.01 hectare to the 0.1 hectare to 100 hectare. So when you calculate a lot of the remote sensing based, the ET, especially on the MODIS scale, and that is not going to work out in the applications what you're thinking about in the MENA level, because of the number of discussions has been discussed on that issues with the pixels. So keep that the background in the mind, and how this really works on the ground. So what the colleagues, the 5 colleagues that presented for the 5 countries ground data measurements, I just put into that one into the ground level, the resolutions, looking into the 1 meters and the 30 meters, and looking into the MODIS level and Landsat level, the ET. And this really clearly shows that the gradient of the ET is happening the different scales, and one ET measurements is not going to work in everywhere, and still there is a lot of the standardization approaches. So they give that in the good perspective, look into the red dot on the ground. So that is about the 30 meter to the 60 meter the pixels, and most of the field sizes. You can look into 3x3 window or 10x10 window, and a lot of the strips planting happens here in the MENA regions, especially in Egypt and upper regions. So the pixels is going to make a huge difference, and the orientation of the field is going to make a difference, and how best you can quantify. From the 30 meter or 60 meter, the Landsat thermal, and look into the 250 meters, the MODIS, and the 500 meters and the 1 kilometer. And orientations of the pixels is really work differently on the ground. So this is what we call a pixels in the fractal approach that brings us to the remote sensing based calculations. And just showing here is the metric based the E-flux, the EG model, and how that's comparison the ground level. So that because of when you making decisions or irrigations, and still is very vital to look at the farming system level, because of each farmer, they follow the different irrigation approaches. So we put enough effort, what they did in the E-flux. We did quite a bit of effort in calculating that in the Siebel-based G model, and to come out of because of in order to comparison with the remote sensing data with the ground measured data, so we need to have a continuous series of the remote sensing data. That's tedious process to get it. Even calculating the one the tile of the Siebel Landsat tile, it takes quite a bit of time. But what's happening since we are using this approach for the long time for the water productivity studies, but very interesting thing happened, the computational power is increased drastically, and that's provided a new dimension for testing the different ET models and comparisons and time series in the spaces time and the real-time applications. Now we're looking into the high resolution data, how best we can bring in Sentinel-2 and Sentinel-3 data into the calculations. So having that set in the ground, in the pixels, the level you are working at the remote sensing, at the end of the day, so that we cannot put the ground stations everywhere, and remote sensing is going to play the vital role in the extrapolations, applications. We cannot just put the eddy coherence tower or surface the energy balance everywhere. And this still, they are very vital in order to validate this one. But now let's look into some of the results I put into this chart, the time. The intercomparison of the actuality for the season 1, and I'm glad that the colleagues that discussed in detail of all those the ET stations, the data collected in those 5 countries. I'm not going to pitch into that one. Here, what I'm comparing this one with the RS-based actuality versus the ground observed ET. So look into this one like Egypt and the R square, the comparison between the ground measured and the observed data, that clearly shows the variations. And also you can comparison of the root mean square error and which one is doing better. So that in this case, the Siebel is pretty much closer to the ground measured. And then you can compare that to the same thing with the Lebanon, and still is off the track because of the we have several other issue that one in the season 1, and then looking to the Morocco, the same issue there too, and then it comes to the Jordan, so that in the first seasons, and Tunisia. So these are the issues we are looking into when we started the ground data collections in the beginning. There is a lot of the issues and setting up the sensors and all things as variables, whether we can keep on making the progress as you move on. So look into the next one, and the intercomparison of the actuality for the season 2, that is the summer season for maize, potato, and wheat, the 3 different crops, so that we have much better the estimations of the ground measured ETR, and that's really the shows. And also like I look into the comparison between these mean root square errors for the Siebel metric and the vapor. And that's also showing the difference. So this is really very interesting, encouraging. I'll tell you why. The Egypt is much higher correlations as compared to the other because of the field size and uniformity, and the spillover impact is much less compared to the hilly areas and say dry pixels. That's what Pascal discussed this morning and all the colleagues. So we can just compare that the maize versus the potato and the beet. And I'm not sure that's because of the field size, one side, also the different crop variables is that calibration is coming to that stage. But the main the idea here is just to look into three. Of course, we're supposed to do it for the simplified energy balance operational, and that model took quite a bit of time to us to put it back to the calculations. So simplicity, just we're using the Siebel, vapor, and metric, and the observations clear that one, like being a Siebel and the metric, the vapor and metric, they follow the similar trend because of the algorithms. So they're following the metric. And also the Siebel, maybe it's because of integration of the Sentinel in the vegetation fractions, and that's maybe a bit improved in terms of the season 2. And see, the season 1, season 2, we have really limited the data points in the one-to-one comparisons. So I'm moving to the season 3, and the intercomparison of the season 3, again, comparison of the winter in 2019 to the winter in 2021. And this is much the better data collections. Data collections improved very drastically much better, despite of the COVID, and because of the colleagues, they learned the lessons in 2020, and they learned this year is much better because of that. The progress is really made a good the continuous series of the data collections. This really giving a nice what they call calibration, the points to address this. So just looking to the Egypt, the metric, the doing the much better. So and next to the Siebel, and in Faba being in terms of the Lebanon, and the both metric and the vapor, it is the underestimation, but the Siebel stream to be still is far away, but they're much closer to the observation data. And in Morocco, again, the trend is the different. And then compare the Lebanon with Tunisia, the cliff between the both, so Siebel and vapor with the metric. And this needs to be the investigated. So why is that happening? Is that because of my quick assumption is that the spillover pixels effect in this case is surface area balance, and Jordan is still the following the trend. So the best things to observe here is that, and we look into the different ground observed databases, and I'll discuss with Ajit and colleagues. They clearly that one, we cannot use the same the ground measurements everywhere because of all the ground measurements of what they're doing it in Egypt and Lebanon and the Tunisia, Jordan, they are not consistent. Because of that, you have to look into individual data in that given stations, which is doing much better. This is where, based on the observed ET. So you look into the comparison for the Egypt, you look into energy balance. That's what much better estimations and continuity. And Morocco and Tunisia use the eddy coherence. They're doing much better there. And Lebanon, the soil, the master depth SMD used there. And Jordan, definitely the lysimeter is doing much better. So these are the three observations. We look into that one. So that now we need to look into what calibration is going to happen and why this variability is happening in the different scales. So can you bring this real-time applications of the ET-based approaches at the ground level, and how this can quantify the soil moisture to much more dynamics to understand ground level. So this is what we have. I'm not sure like the Vinay's time is, you said, finish it in 7 minutes. I think I'm there almost. And thank you very much for this, everyone, and especially the colleagues on the ground. They're working so hard to put the data. And we're happy that at least the season 3 and now season 4 going to be much the better data collection that providing the really ground data validation points you can address much better. So I'm skipping a lot of the slide here so that here I will end because of the time. Over to Vinay, Rajit.
Hossam, can you unmute Ajit? He's saying he got muted by default somehow. He can't unmute himself. Hossam, can you help?
He can now, yeah.
Okay, Ajit.
Thank you. Now I can unmute myself. Yeah. So maybe we will take, because of the lack of time, we will quickly go to a question from one of the audience. Saib Nisa from Egypt is asking the question to Dr. Reen. April and May seems critical to the measurement of ET, and she says that studying remote sensing based crop parameters with along with ET measurements are maybe important thing to do, especially in the case of agro ecosystems. And what are your thoughts about that, Dr. Reed?
Yes, we don't have a particular problem with April and May. There are periods perhaps where we could have some gaps, but it is not related to these months. We have no problem, particular problem in observation with this month. And we did the measurements of the we follow the crop phenology, the leaf area index, and the biomass during the experiment.
Thank you. So I have one question to Dr. Ihab. What do you think is the need for a consistent and standardized protocol for such a network to operate, and also to develop data sets that are useful for validating remote sensing based retrievals? And I would also like to hear from Dr. Chandra. With this, we will, after their reflections, we will quickly try to wrap the session. Thank you.
Yes, Dr. Rajid, you were asking me about the standardizing of the data throughout the whole region. Yeah, that's a big challenge also to work, because to work on, and especially once you standardize the data collection, you will be able to compare the data collection accuracy between all the countries easily and be interpreted faster. So that goes into the same direction. And at the same time, as Dr. Chandra was also presenting, it will be easier also for remote sensing data to be comparing the data collection between the different countries. That's my thought. Thank you.
Thank you. Thank you. What do you think, Chandra? You presented very good results, and what are your reflections on the need for a consistent set of ground observations for remote sensing validation?
Yeah, I just presented for the season 1, season 2, and season 3, and we started comparison with that one. So that's really, it shows that the progress we have made in these seasons, because of we not have any good calibration data so far. So as we have been using the remote sensing based ET to do the water predictive mapping last 20 years without the calibration. Though still we are sticking with the uncertainties what Pascal mentioned, that anywhere between 3 to 10% of error margin, even there's more, but still that we said that there is nothing option, so you have to go with that. But having this kind of the ET network is established now, it's already making the new room. Once this kind of the real ground object data available, and that open up the lot of the researcher to start looking into what are the uncertainties there. And again, the results clearly indicates that not a single the ground object is working everywhere. And same with the remote sensing. So this really we need to be quantify, and what kind of the ground measure it is good for the in the morning someone asked for the MN, and what kind of the ET I use for my country, the same thing coming up with different people. And this is really the startup. And result is clearly showing up now that at least we know some systems work in some regions, some not work in other regions, and now we have to find out why it particularly is not working, and what kind of remote sensing really make a difference in terms of the terrain and cropping systems and crop types and the field size. Thank you.
Thank you, Dr. Chandra. May I invite Dr. Alhamdi from FAO to show give his reflections and also to wrap up this session.
Thank you, Ajit. Thank you. And I'm really happy that we have had this 2 sessions back to back. Can you hear me?
Yes, yes.
Yeah. I'm really happy that we've been able to organize these 2 sessions back to back. And I'm really impressed with the let's say the quality, the amount of science that has come out in these 2 sessions. It's very impressive. And I think one thing that we may want to, in the future, link is not only to engage very technically in depth. Well, this is very important, very useful and needed, but also there are aspects that we probably need to connect. The science, and here there is a lot of science, the science policy interface. There was a comment in the previous session which says in the SDGs, the SDG indicator 6.4.2 indicates or reflects withdrawal. And here we're talking about consumption. And we can see that between withdrawal and consumption, there is a policy intervention that has to come place. And that intervention, that policy intervention is important because that leads us to more sustainable water management. So I can appreciate all the work, and I really am thankful to Ricardo and to Pasquale and to all the efforts that we've been doing through the last couple of years on ET. But I think we really need also to engage beyond only the technical elements of the ET, how we measure, how we standardize, and how we use the remote sensing. The remote sensing is going to provide data more readily available, cheaper, etc. And it would allow for wide upscaling to large areas. However, I think it's really important to keep this in mind, the connection between science and how it reflects policy, shaping policies on this. It's important to provide farmers with directions on when and how much to irrigate, but that is a double-edged sword because it actually, what it does, it provides a higher water productivity to the farmer, more income, and in some places, what they do is they expand. And I can understand in Egypt there is limited space, but in other countries, what they do is they expand, which actually ends up with more demand for water. So if we're looking at ET within scarce water region like ours, we really need to keep the linkages between what we do in the science sphere and connect that on how to reflect that to appropriate policies. We need to reflect this into directions where decision makers are able to make use of this so that we do more sustainable management of water. I know I've taken this broader and IBIRD view, but I think we really need, in addition to the good work that we're doing at the technical level, also consider this aspect. This has been very useful. I've learned a lot. It's good to also hear colleagues from the different countries. I think this has been very useful to me at least. Thank you for organizing the session, colleagues from ICARDA, and back to you, Billy. Thank you.